Namaste to everyone. So, a very grand welcome to this weekend's Mahabharat. As I have already told you that I am going to start Indian history series, the complete Indian history from ancient India through the medieval India and via modern India. We reach the contemporary India until today. I want to discuss in complete details about everything, the social domain, the economical domain, the political domain, and almost every corner of what is actually India, what was actually India. So these concepts will be covered in coming lectures. So yes, as a subtopic of this major Indian history series, today I am going to discuss two important concepts. So this is the first class of Indian history. This is my style of versioning of Indian history. That means the storytelling, I will have my own comfort to tell the story in my own view, but the facts will remain the same. But the storytelling will generally vary because I want to make you all enjoy this Indian history. Enjoy. This is not to be memorized. This is not to be burdensome, to be felt too burdensome. No, Indian history, as we are Indians, first of all, not to preparing for government exams, not to prepare for some jobs. Just because we are Indians, we should know what is actually the history of India. So this is my vision. My vision is not to make you clear some jobs, you to go into some government sector through this preparations. No, this Mahabharat initiative's main vision is public education. So please understand. So there will be some difference between the coaching centers classes and my version of what India is. There will be distinctively the differences will exist because I will always put nation or the unity of the nation first, than the personal benefits like getting job by memorizing the facts of Indian history, by teaching the Indian history. No, this is not my vision. Mahabharat's vision is actually to understand Mahabharat, the great India. Yes, so as a subtopic of this Indian history series, today's subtopic this lecture deals with two important aspects. As we have to start with Indian history today, as the first class of Indian history, I want to take you back very far away in this vehicle of time, very far away. You have to be ready. Please be ready. If you have some disturbances around you while watching this video, please come out of that. Be comfortable, and because this is a very beautiful journey that we have to learn. If you are learning something, learn 100%. If you are learning something, please learn 100%. Don't see just for to test SRK, that whether he is telling correctly, whether he is telling rightly or not. See, I do my homework because this is my vision. This is not my time pass lecturing. Yes, the subtopic for today is, how did universe come into existence? See, because to understand Indian history, first of all, let's start the story from there itself. First, how did the universe come into existence? After that, we will come to how India got formed, how the history of India went. So how did this universe come into existence? So this is the first part of our video lecturing. We'll go in that way. We will discuss how did the universe come into existence in the first half, and the next half we will discuss that how did life come into existence, because if there is no life, there is no India at all per se. So I thought, starting from the starting of the universe itself can be a very better start to understand the complete time spectrum as a history. So please be ready. First topic, we will take the first topic, that is, how did universe come into existence? See, why we have to study? You may all experienced that in the summer nights, if you just sleeping on a cot and watching or staring at the sky from the small pores that exist in the tree leaves, the gaps between the tree leaves. I don't know whether you or not, whether you did or not, but I used to stare at the sky and I used to see many stars in that night time. I used to think when I was fourth class or fifth class that, how did these stars, who created these stars? There was a huge popularism that God created this when I was fifth class old and when I don't know anything. Lord Brahma has created this. And all these stars are actually the servants of Lord Brahma, the great God, that is Indra, servants of them. We call them as Ashtadikgajas, etc. So these were some mythological stories around the formation of the universe. The main popular story was that from the Lord Brahma's different parts came out different, parts of the universe, like Purusharthas, even the people, the caste system, everything was related to Lord Brahma's activity, the creative activity, the creativity of the Brahma. So this was when I was fifth class year old. But now we are a little mature, now we are educated, now we know that no, this is not a believable version of things. We should always rely on the facts. We should always rely on the evidence. That's the way science works. So everything starts with astronomy. Very important to study history. First of all, you should start with astronomy, in my view. The moment you understand astronomy, you will understand the space. You will understand how did the universe came into existence. And then slowly you will understand the formation of different physical bodies like planets, like stars, and then comets, asteroids, etc. Because the playground has to be set up to play the game. And this game of humanity was too late, actually. There was a huge time spectrum, huge history before the humans came into existence, first of all. So in my view, to understand Indian history in 100% beautiful way, we have to start with astronomy. That is the universe. How did the universe come into existence? So upon discussing the mythological stories that around the creation of universe, when people actually don't know how actually universe created, in 1750s around, if you see about this concept, when did this debate come up on the world stage, that how did the universe come into existence? Normally, if you see every scientific concept, if you say astronomy, physics, biology, chemistry, every scientific discipline started its birth after 1750s, after industrial revolution, just after that, starting of the industrial revolution, because that's the industrial revolution is the result of that renaissance, re-looking into the facts, re-looking into the belief system. From there originated this science. And that led to the industrial revolution. So many scientists were actually started thinking about this question. How did the universe come into existence? Is it true that Lord Brahma of India created this? This is what might be thinking. They might be thinking, the other European scientists. They don't know even who is Brahma, per se. Then, a fun about, many universities exist in the world after 1750s. And in every university, you will see research activity will go on. Cambridge, Oxford, like that. These are the two popular universities generally in the European era of that 1750s. So, in one of the universities, there was a scientist actually working upon this concept of how did the universe come into existence. So let me just brief you about how he was researching this concept. I will tell the person's names later, but per se, imagine that there is a scientist in the Europe around 1700 and around 1920s. This is what happening around after 1900, let's say. So this scientist, he had a telescope with him. He had a telescope with him, a small underdeveloped telescope. So he was always, every day, out of his passion, through that telescope he was looking at the sky, and seeing, he was so enjoying the beauty of the sky. And in that enjoyment, he was thinking at the back of his mind that, "Arey yaar, what is happening in the space? How did this universe come out? What is the main characters of this, main principle of this universe operation, mode of operation?" So he started looking at the sky every day in that telescope. For 1 year, he did the same. He always used to map out the stars. He always used to map out that, galaxies, and he used to measure the distances between each galaxy every day. Every day he used to measure the distances. How? Do you know, in astronomy, the distance between galaxies will be measured with a unit called as light year. Light year. What is light year? Generally, see, on the land, in our right now, if you see, to explain you, generally distance is measured in kilometers or meters or in some distance units. But in the space, if you go, it's unending. It is infinite in nature. The space has no ending. So how can you measure with the very, very limited distance units? So that's where came this light year idea. Normally, as we know, that light actually travels with a velocity of 3 lakh meters per every second. 3 into 10 power 8 meter per second. This is the velocity of the sound in the space. So what this scientist was doing was, actually, he was calculating based on this light year theory, light year concept, the distance between every galaxy. That means how many, for example, in 1 year, how much distance light particle travels. So that distance is called as light year. So like that, how many years the light may travel from one galaxy to another galaxy, based upon these reflections calculations, physics, fundamental physics of light, he was calculating the distances between these galaxies. Every year he was doing the same thing out of his passion. 2 years gone, 4 years gone, 5 years gone. After a decade has been passed, he has a huge collection of a decade observations, the distance between the galaxies. After this huge time, a huge effort, he observed a pattern in the results. He was shocked. In 1920, this scientist of Europe, one of the universities of Europe, he was too shocked by his observations that the first observation that this scientist actually observed was the distance between the observed galaxies was improving over time, was increasing over time. He was too shocked. That means the two galaxies are going apart. Every year they are going apart. This is what one observation. It made too curious to him. And the second observation that he got was, even the galaxy itself. Galaxy means, I will tell after that. Just I think I assume that you may imagine what is galaxy is. Galaxy is, to a simple word, it's a collection of different materials, maybe the energy and matter, different accumulation of this matter and energy. A group of cluster of bodies of matter and energy is called as galaxy. So that's the first observation. The galaxies were moving apart, and the second observation was the galaxy itself is expanding. The distance within the galaxy also, the bodies are actually separating apart every year. So this was the observation that he had. He was too shocked. He was so surprised to see this, and he wants to publish it over. And he published a paper in 1920. And he proposed a theory to explain based on these two observations. He proposed a theory upon the observation that galaxies are moving apart. At the same time, within the galaxy, bodies are moving apart. So with this crux, he proposed a theory in 1920. That is Big Bang theory. It's the most popular theory to explain the origin of the universe. And this scientist who proposed this theory of Big Bang was Edwin Hubble. So Edwin Hubble in 1920 in Europe proposed this concept of Big Bang based on the two observations. He also gave a small model to explain how the universe was actually expanding, and that model was inflating balloon model. That means he told that, see, look, you first have a balloon which is uninflated, and you mark 2 points on them and imagine them as 2 galaxies on that uninflated balloon, and you start inflating that balloon slowly, so that what happens, the balloon will inflate it, and then the marked points will actually leave apart. The distance between the marked points on the balloon as you are inflating the air, then the distance increases. So he said that this is exactly the way the universe is actually in mode of operation, expansion. And the second point he said was, even the marked points, if you see, when on the uninflated balloon, he marked 2 points with a diameter of, let's say, 1 centimeter, 1 centimeter. But as you are inflating, the points themselves are becoming 2 centimeter, 3 centimeter as you are, giving in the air, blowing in the air. So these are the two observations. The galaxy is increasing, expanding, and the distance between galaxies is expanding. And he said, with these observations, he proposed, as I said, Big Bang theory. So now, here starts our first concept, that how did universe come into existence? According to the most popular theory till today about the origin of a universe, which was proposed by Edwin Hubble of Europe in 1920, was Big Bang theory. So now we will see what actually he explained. What is Big Bang theory and how did universe come into existence? So he said that first of all, this universe there is nothing in this universe before 13.7 billion years ago. Please, from here you please note down these facts. Maybe they are important. In state services examinations, in national examinations, generally these facts will never come in encounter. So as I told, before 13.7 billion years ago, in this universe there is nothing. It was completely vacuum. Only space existed, but except a small point in the universe. A small point, it's like a small tiny ball, a very small atom, only one atom, slowly a very small atom existed in this universe before 13.7 billion years ago. So now we are at 13.7 billion years ago. What is 1 billion? 100 crore years. 1 billion is 100 crores. 2 billion, 3 billion, like that, 13 billions. That means 1300 crore years back. 13.7 billions. That means 1370 crore years back. That's what we are to be now. So now you just imagine that this is 13.7 billion years ago. We have nothing in the universe. It was completely vacuum. But there existed only one point. One point in that universe, in that huge universe. And that point actually contains, Edwin Hubble said, the first point of Big Bang theory, he said, the first point was, all the matter that we are seeing today, planets, stars, energy, earth, and all these life forms and everything, the physical matter, complete physical matter, everything with which this universe was made up of, was contained in that small particle, in that small point, singular point, and he called it as the point of singularity. Points of singularity. So now you imagine, all this was not there before 13.7 billion years ago. It was only vacuum. But all this matter and all this energy that we are seeing today was compressed in a single point, in a single atom, in a single tiny ball-like atom called as the point of singularity. Here comes the first question of us. Is it true to believe? Is it true? Is it possible that this huge vast universe, complete physical material, to be compressed in such a smaller volume, a small single point? Is it possible? Here the explanation for this question is very simple. See, physical material changes its value upon the action of the temperature and pressure in result of density. For example, if you take water and you heat it, you add temperature to it, you increase the temperature to it, it will change its state. First of all, from liquid state to gaseous state it goes. In the liquid state, it may occupy a volume of 1 liter, but in the gaseous state, it wants to escape. If you see just in the container, if you have a 1 liter liquid volume and you add temperature to it inside the cooker, let's say, imagine, as the water is becoming gas, it wants to escape because it needs huge volume. The gas molecules are too separated, not unlike the liquid molecules. So you can imagine here the conclusion, the crux is that if you change the temperature and pressure conditions, normally matter will change its value. So it's not too amazing, not too wonder, not too miracle to believe that yes, the complete universe was compressed in that just very small point of singularity, which is less than 1 nanometer. Please imagine 1 nanometer, less than that. That's the point of singularity. In that, this complete universe was compressed. This was possible because of the two conditions. The first condition was Edwin Hubble was saying all these things in the Big Bang theory. So the first condition to satisfy this point of singularity was infinite temperature. So he was telling before 13.7 billion years ago there was nothing in the universe, only point of singularity, and that point of singularity inside it has infinite temperature. This is what he is saying. And the second point, because of this infinite temperature and the compression of complete matter on a single point, there is huge density inside that singular point. Huge density. So the crux is, the conclusion here is, under infinite temperature and infinite density, all these atoms, all this matter, the physical matter of the universe was actually before 13.7 billion years ago compressed in a single point. Clear? Now you can imagine in a pressure cooker, as the temperature got increasing, as you are boiling the water, as the temperature increasing, the gaseous molecule which was actually evaporated from liquid molecules, they want to escape and they will always lift up the lid of the cooker. You may know it, because it wants to escape, it wants to occupy more volume, so it always puts pressure, huge pressure from inside the cooker, and it wants to lift up the lid of the cooker. In the same way, at 13.7 billion years ago, in this single point, because of that huge temperature and huge density, all the matter and energy was actually succumbed into that point. Because of that huge conditions, huge extreme conditions, it wants to explode. At one point, all the matter and all the energy which was there, which was restricted in that point, wants to escape. Yes, you are feeling it, right? So that was the point. 13.7 billion years ago, there came the opportunity to that huge pressure built point of singularity to explode. So at 13.7 billion years ago, there was a huge explosion from that singular atom. From that single atom, huge explosion, a violent explosion has happened. Violent explosion, and that explosion is called as Big Bang. Big Bang is nothing but a violent explosion of matter and energy, which was succumbed into the singular point before 13.7 billion years ago. So a huge explosion happened. This was the first point he explained, Edwin Hubble. And the second point he said was, once the explosion happens, what generally happened was, all this matter and energy got distributed in the universe. Before that, as I said, there was nothing in the universe. But now, all this matter and all this energy which was there got spread in the universe unevenly. This is most important point, because it is an explosion. Let's say, to be very clear, it's an explosion. So in the explosion, you cannot expect a uniform distribution of matter. So normally, all this matter which was exploded, all this energy which was escaped from that point of singularity, got dispersed in the universe in an uneven way. uneven way. But because of the huge thrust that was created before the explosion, during the explosion, because of that thrust, all this matter is separating even till today, is expanding even till today. So this is what Edwin Hubble was actually observed in the starting of the hypothesis that he put forth. So he observed that universe was expanding by the experiment of telescope and calculating the light year distances between galaxies, and he came to the conclusion universe was expanding. So he went back in thinking from there. So now we got to that position that after the explosion, all the material, matter and energy got dispersed in the universe, and it is till today, sir, please listen, till today, this expansion is still continuing, but in a very low rate comparable to the era of 13.7 billion years ago. So the second point got very clear, energy and matter got dispersed in the universe. And the third point, this Edwin Hubble, he said was that after Big Bang event, please imagine, after Big Bang event, just after 3 minutes, the first atom got formed in the universe. First atom was formed. The physical material which was exploded from that point of singularity got transformed itself. That matter transformed itself into the formation of an atom. So the atom was first formed after 3 minutes of this Big Bang event. So this is the third point he said. And the fourth point Edwin Hubble said was, because of the huge temperature and huge density conditions in that point of singularity, Big Bang event happened. So once the matter released, once the energy released, normally we can expect that temperature will slowly go down. So that huge pressure will never be there, that huge temperature will never be there. So the next point Big Bang theory said was, as the time progressed after Big Bang event, normally the temperature in the universe started calming down. Very important point. Started coming down. So he gave the fact that after 3 lakh years after the Big Bang event, 13.7 billion years ago Big Bang event, from there 3 lakh years passed. Now, after 3 lakh years, the temperature at Big Bang event was some 100 times more than what was the temperature at after the 3 lakh years. That means temperature is coming down. So after the 3 lakh years of Big Bang event, the temperature got cooled down in the universe to 4500 kelvins. Before that it was some 100 times bigger, because infinite temperature, we are using the term 100 times, some thousands, some lakhs and millions of times greater than this 4000 kelvins. But after 3 lakh years, the temperature cooling down now, so it came to 4500 kelvins. Please imagine that matter and energy will always change their states, will always change their composition upon under such certain temperature and pressure conditions. So because the temperature is coming down, now changes appear slowly in this dispersed material, in this dispersed energy in the universe. Till now we don't have planets, till now we didn't have stars formed, nothing else. We have only just matter and energy got dispersed. So at 4500 Kelvin temperature, after 3 lakh years of Big Bang event, this physical matter actually started forming into atoms. The first atom got formed after 3 minutes itself, but actually in mass numbers, all the energy was converting into atoms at this temperature, 4550 kelvins. So the atoms are started forming. That means smaller particles, very dust-like particles are forming from the energy, from the transformation of energy to mass and atom, already existed matter. Now the fourth point what he said was that actually universe is expanding and it will continue to expand, because he said that even till today is also it is expanding. So even in future also the same trend will continue. This is what he said. So Big Bang theory is this. These are the 4 points. All the matter got confined in a point of singularity before 13.7 billion years ago. After the explosion happened, and then it led to the expansion of in the universe, expansion of this matter and energy started, and as the temperature is cooling down, the energy was converting itself into matter and atoms started forming. This is what the Big Bang theory of Edwin Hubble was. In 1920, it was a huge hit journal to the world itself, world science, astronomy itself, because Big Bang even nobody could tell with facts till then about how did the universe got formed. And naturally, you can expect to every hit subject there will be some opponents normally who contrasts the popular theories, and it has to be there. Criticism should always be there, because then only growth will happen in science or technology, and in per se in thinking of humans also. So in Europe, after Edwin Hubble proposed this Big Bang theory, there was another theory came up in counter to this Big Bang theory of Edwin Hubble's theory. So that second theory which was in counter to this Edwin Hubble's theory was Hoyles theory. Hoyles theory. So what is Hoyle? What is this Hoyles theory? See, this Hoyles theory says, no, Edwin Hubble was actually mistaken. All this Big Bang theory was rubbish. The universe, what Edwin Hubble said, he said that the first point, universe got expanding out of his observations. From there he started, and he went back in thinking, and he created this story of Big Bang. Hoyle was saying all these things. Actually, Edwin Hubble was mistaken, because see, this is a dynamic universe. This is what Hoyle is saying. This is a dynamic universe in which we all are in movements. Our Earth is completely revolutioning about Sun. Earth itself is rotating about itself. So normally, if you measure the distances between moving objects, it will never be accurate, because every particle in the universe, every body in the universe is in motion dynamically. So he said, no, Edwin Hubble was completely mistaken. Because of this dynamic nature of our universe, naturally distances are changing. That's the only reason. Because of this, he was mistaken that universe is expanding. Hoyle said this. No, universe is not expanding. It is just the dynamic motion. Because of the dynamic motions, calculations are not completely accurate. That's where comes the differences between the galaxies, distances. That's what he said, and he countered that no, first point was wrong. Universe was not expanding. It is constant. Hoyle's theory. That means he completely countered the Big Bang theory. The moment universe is not expanding, if this statement is wrong, all the Big Bang event theory would be wrong normally. So that's what Hoyle's theory was countered. But most of the scientific community backed Big Bang theory only. Hoyle's theory was not, it was disregarded. It was not considered, and it was not popularized. So even till today, Big Bang theory was actually the explaining popular theory of the formation of the universe. Now, in our story, where we are, so the first atom got formed after 3 lakh years because of that cooling down of the temperature. Now, see, after explosion, matter and energy got dispersed, and I said it was ununiform. It was non-uniform, not uniform. Yes, that means here and there, matter in the region, in the space, matter is not same. Normally, in particular region of universe, some huge matter was concentrated, and in some portion of the universe, in space, there was no matter at all, and in some portion there is huge energy accumulated, and in some other portions there was no energy. Because of this explosion, violent explosion, these spreading, this distribution of atom and energy was non-uniform. Yes. So because of this non-uniformity in the distribution of matter and energy after the Big Bang theory, after the Big Bang event, there existed the density differences between the regions of space. Yes, here huge matter was accumulated, so more density. Some other region of the space, there is no matter at all, so less density. Here huge energy got accumulated, so more density. And in some other region of the universe, there is no energy at all, so it was completely energy will never be absent, but lesser energy, that means low density. My point here to tell you is that Because of this non-uniform distribution of material, matter and energy, density differences came. Density differences. See, the moment density differences are there, please understand, the moment density differences are there, because of out of these density differences, they established a force between these two regions. They established a new force. A new force was taken birth out of these density differences of the space of the universe, and that force which took the birth between these two different density regions of the space was gravitational force. So what is gravitational force? What we are studying in our textbooks, G is equals to 9.8 Newton per meter square, etc. on the earth. So these values, this G is actually the gravitational force. So this gravitational force was actually taken birth out of this because of this density differences in the regions of space. Yes, gravitational force was formed between high density regions and low density regions. So normally what happens? The distances, the attractional forces, smaller particles will be attracted by the huge density area. Smaller, in some places, if huge matter was accumulated, that will be dispersed to the less densified areas. So this gravitational force was created, and this force was actually the reason for the redistribution of the material. So now, see, because of this gravitational force, what happened was, if there is a bigger body present, bigger matter present in the universe after the explosion at some particular region, it used to attract all the smaller particles which are around it. That's the role of the gravitational force. So what it made actually, it backed the reason that the accumulation of gases, all the energy that was spread out due to the Big Bang event, that energy got actually together because of this gravitational force. That means huge gas accumulation was started because of the gravitational force. Huge in concentrated areas, in concentrated regions of space, huge gas accumulations, gas clouds are forming. Gas is nothing but the matter which came out of the Big Bang event, and energy is gravitational force. So energy became gravitational force, matter became that gases. So gases are coming together under the influence of gravitational force. Here and there lumps of gases are forming, and this large gas accumulation is called as galaxy. So I told them what was galaxy. I will tell in the latter times. Yes, so in the starting of the video, and this is what is galaxy? Galaxy is nothing but it's the huge gaseous accumulation because of the gravitational force between the gas molecules. These gas molecules will come together and a huge gas will form a cloud, and that is called as the galaxy. Yes, so galaxies are formed now. Galaxies are formed. So this is what happening from 13.7 billion years ago to some around 6 billion years ago. Before that, so in between that time, this is what happening. Galaxies are slowly forming, and in that, till then there were no stars. Till then there were no planets, no asteroids, no comets. Only gaseous clouds were there, first formed. Now imagine, because of this huge accumulation of gas. See, I forgot to tell, what is that gas actually? What is the element of that gas? In that point of similarity, as I have said, infinite temperature was existed, infinite density was existed. You can imagine what that gas would be. It is hydrogen and helium. So hydrogen and helium are the first elements, first gas which formed in this universe. Those gases will only give that much of heat. They will only survive that much of temperature. So galaxies are formed, the accumulation of the gases. Which gas? Hydrogen gas. So when these gases, because of the gravitational force between them, are coming together and densifying themselves, and they are forming into a cloud, that cloud is called as, densified cloud is called as nebula. Please remember this point. That densified cloud is called as nebula. Now, so this nebula, if you see this nebula, Because of this huge densification between the gas molecules, what happened was heat got concentrated inside that gaseous cloud. Heat. And what the gas contained in that cloud? Hydrogen. So hydrogen gas clouds, that is nebula. We can also call them, if they are loose, we call them as galaxy. If they are too densified, we call them as nebula. And these hydrogen gas clouds, inside which gravitational force was also there, getting densified and heating up inside, that heat energy of that hydrogen element under the heat starts producing light. This is just a thermodynamic event, that is conversion of the heat into light. So inside the gas clouds, hydrogen was there. Hydrogen under the heat now started producing light. So this gaseous cloud which started producing light is called as star. So here and there some lumps of gases were, as I have said, densified under the influence of gravitational force, and it got densified and its internal temperature increased, and hydrogen, because of the presence of the hydrogen gas under the heat, started emitting the light, and that's where the formation of stars happened. And now let's come closer. This is around 6 billion years ago happened. Stars formation was happened around 6 billion years ago. Now stars got formed. The star Sun is also one among them. So the age of the Sun was roughly to say 6 billion years ago. 6 billion years. Now stars formed. See, you can imagine, what is star? Star is a gaseous accumulation which is densified, and inside it there is gravitational force and a huge heat, and that heat is becoming light. Now you can imagine, in every star there is a lump of gas. In every lump of gas we have gravitational force, and upon the densification of this gaseous cloud, what happened was that gravitational force which was actually inside that gas cloud started becoming and acting like a core to the gas cloud. So this gravitational force became the core of what? This gas cloud. Please follow it. Don't neglect this terminology, very important. So the gravitational force which was actually inside the gaseous cloud, which is emitting light, and we call them as stars, that gravitational force started forming the core to the gaseous cloud. And all the gas that was around this core, that is gravitational force, now started forming slowly a disc-like bodies around that core. A small disc, even the stars themselves, the gaseous cloud around it, forming some disc-like material, disc-like objects. And as the time passes, as I have said, after Big Bang event, the temperatures were slowing down slowly. So now we are at 6 billion years ago, stars formed. Temperature still further down, is still furthering down. So because the temperature is coming down, this gaseous cloud around the gravitational core is now started condensation process. Condensation. What is condensation? Condensation is nothing but the transformation or the change of the state of matter from gaseous state to liquid state. That means around the gravitational force core we have gaseous cloud, and this gaseous cloud is now started condensating, becoming liquid, or it is like, you can imagine, on every cool bottle, Sprite bottle, let's say, and if you just take it out from fridge, you can see all the surrounding air will condense on the bottle outside, and you will see drops of water completely stuck to the bottle surface. In the same way, just imagine the bottle as the gravitational core, and all the gas which was around it was condensating because of the lowering of temperatures around the gaseous core. And as the temperature still further down, even these liquid particles which were condensed to the gravitational core now became solids. So now you are understanding how a solid round body is about to form with a gravitational force core, inner core. So these small rounded bodies which were actually formed from the gaseous clouds are called as planetesimals. Please remember the terminology, very important. These are called as planetesimals. See, these planetesimals are here and there single small gaseous cloud. They made out of small gaseous clouds. Now, because of the gravitational force existed between even two different planetesimals, cohesion force will generally be developed, and because of that cohesion, two different planetesimals came together and stick together. They become a larger body, and like that, this process of accumulation of different layers, planetesimal 1, planetesimal 2, planetesimal 3, gaseous clouds, they are nothing but became solid, and these solid bodies are sticking each other because of the gravitational force, and this process of layering is called as accretion. Please remember the term, very important, accretion. So out of this process of gravitational force dominated accretion process, they formed a large bodies which were in the form of rounded bodies, and they are called as planets. So now you understood, planets are formed out of the gaseous material, gaseous cloud. Some planets were even formed out of the stars. Remember, please mind it, this is also fact. So now planets got formed. This happened after the formation of stars. That means stars formation happened around 6 billion years ago. After 1 billion years ago, after 1 billion from there, that means around 5 to 5.6 billion years ago, 5 to 5.6 I am saying, sun was formed. Sun, our star sun. From 5 to around 4.6 billion years ago, this planet accretion process was happening, and about 4.6 billion years ago from now. Please remember, this is very important. From 4.6 billion years ago from now, first planets started forming. So our Earth is a planet. So Earth is also formed when? 4.6 billion years ago from now. So chalo, our Earth has formed out of the gaseous cloud with a gravitational core which was condensed upon the cooling down of temperature, and upon still cooling down of the temperature it became solid and solidified, and different planetesimals combined together to form a larger body called Earth. So let's be specific from here. Now we come closer to the history of Indian history. We are going to be closer. 6 billion years ago, now we are at 4.6 billion years ago. The formation of Earth happened. Happy, Earth was happened. Now, to be specific, to explain this formation of Earth, there are different theories existed. Just like the formation of universe, Edwin Hubble theory, Hoyles theory, etc. Even to the Earth, there are some scientists or astronomists or per se physicists explained the formation of even the Earth specifically. So let's discuss for them also some 5 to 10 minutes. Specifically, how did Earth form? This was the question. So the first theory which came in 1750s proposed by a very famous German philosopher and scientist. He was Immanuel Kant. So Immanuel Kant in 1750 proposed a theory about the origin of Earth. That is, he said Nebular Hypothesis. Please remember terminology. Immanuel Kant said and explained Nebular Hypothesis. So what is this Nebular Hypothesis? He said, already I told what is nebula. Nebula is nothing but a densified gaseous cloud. Yes or no? Yes. Now, Immanuel Kant said, because out of this densified gaseous cloud, which is actually associated with a youthful sun. Youthful, I mean, there will be some star, let's not sun, but there will be some star around which this gaseous cloud, nebula, was rotating. And from there, because of this dynamic rotation out of the gaseous cloud, different portions got separated and they became different planets and they started revolving around the sun. This is what the theory, Nebular Hypothesis, proposed by Immanuel Kant in 1755, and one of such revolving material was Earth, he said. In the same way, all other planets also formed. This is what his theory was. And after some 40 years, another theory came, that is revised theory, we can say revised nebular theory by second person. You all might have known that a famous mathematician called Laplace. Yes, you have listened right. See, Laplace in 1790, after 50 or 40 years from Immanuel Kant's theory, he just revised it. He said that yes, out of nebula, that means out of the gaseous cloud itself, planets are formed. But they are formed just because of the presence of a youthful sun in center. He said, just because this gaseous cloud is revolving around this sun, because of the heat, some fractures are happened and they got separated and they became planets. This is what the revised theory of Immanuel Kant, that is proposed by whom? By Laplace. So 1790, this is second theory which explains the formation of Earth. And the third theory which explains the formation of Earth was, it was by Chamberlain and Moulton. They are two different scientists who worked on this Chamberlain and Moulton theory. What they said was, see, they said actually only solar stars were formed around 6 billion years, 5 to 5.6 billion years ago. Sun was also formed, but this formation of sun was not completely spherical. This is what their theory was. When the sun formed, solar surface was formed, it was not completely spherical. There is a projection on the solar surface when sun was formed. That projection is actually in the shape of a cigar. This is what Chamberlain and Moulton was saying. It was in the shape of a cigar, and this cigar was projected out from the solar surface, and they said that there is a wandering star in the universe which actually approached this sun around 4.6 billion years ago. And when this wandering star approached the sun, this projection, the cigar shaped projection, actually under the influence of gravitational pull of whom? The wandering star got separated out of the solar surface. And the moment wandering star goes away, this separated material, the separated cigar shaped portion from the solar surface, started revolving around the sun. This is what the Chamberlain and Moulton theory. So, a portion of that cigar shaped material was planet Earth. This is what they said. And there is another theory, the fourth theory, which explains about the formation of Earth. That was binary theory. Binary theory, in the name itself, we came to understand that this people said actually sun and earth were coexisting. Earth was not formed out of sun, they were coexisting. This is what binary theory said. Very simply they said coexistence. One not formed out of another. This is what they said. But see, these are earlier theories, but the most recent and most popular accepted theory was actually come from two different scientists who worked on this. They are Otto Schmid of Russia and Carl Weizsäcker of Germany. So Russia and Germany, two different scientists, they came together, Otto Schmid and Carl Weizsäcker. They both came and they proposed revised nebular theory of Immanuel and Laplace. So what is this revised nebular theory? They said, yes, out of the nebula itself, nebula means gaseous cloud, out of the nebula itself, because it is rotating around sun, planet Earth was formed. But they specifically said that actually on the solar surface, because on the solar surface they said there is some gaseous cloud actually existing around the sun. There is some gaseous cloud was existing when sun was formed, that is called as solar nebula, and this solar nebula actually got separated out from the sun and formed different planets which was revolving around the sun today, that is planets. So this is what the Otto Schmidt and the Carl Weizsäcker's theory. In all the theories, if you observe, the simple point, common point is that there is a gaseous cloud formed, which is I have already told you that how did it form, because of the gravitational force acting as the core and pulling all different gas particles, forming the cloud around it, that became stars in the time. After that, in some of the stars, because of the lower temperatures, they could not become star, but they become planets by how? Solidifying, densifying themselves into solids. So Earth got formed now. We have seen the most important things to be understand here, that how did the universe form? The universe formed out of the Big Bang explosion, which was happened around 13.7 billion years ago. After that, due to the density differences, gravitational pull established. Because of the gravitational pull effect, matter got coming together. Because the matter got coming together, gaseous clouds formed, and because the gaseous clouds have gravitational force inside it as the core, they started densifying. Because of the densification, internal heat increased. Some of the gaseous clouds became stars, and some other gaseous clouds became planets. So this is what the story, this is what how the universe, and this is what how the Earth got formed. So now we are in the timeline at where? 4.6 billion years ago, our Earth has formed. So now let's see the second portion of our today's subtopic, that is how life for the first time evolved, for the first time came into existence on this Earth. Now from now our discussion will go around Earth. So let's see, let's take a small break. This is a almost I think 20 to 25 minutes, I don't know. So take small break, some 5 minutes break, and after that we will discuss the second portion, that is how did life come into existence on this Earth. Thank you.